In this video, we're going to practice multiplying and dividing rational expressions. This is section 5.9 in Al Grosch's book, Developmental Math 2. Practice examples. So we're going to start with a few multiplies here. We practiced in the lecture multiplying these fractions by breaking them down to prime factors and cross-canceling. So that's what we're going to do here. Prime factors for 20, 2 times 2 times 5. Prime factors for 24, 2 times 2 times 2 times 3. And you guys can pause the video, do your trees over here if you need to. Okay? I'm not going to show the trees anymore. Prime factors for 6, 2 times 3. Prime factors for 4, 2 times 2. And now we can cancel anything that matches either vertically or diagonally. That leaves us with 5 over 2 times 2, which is 5 over 4. All right, same idea here with the variables. A cubed, a times a times a, b to the 5th, c squared, times b squared over a, c squared. And then we're going to cross cancel. One of these a's will cross cancel. A couple of these b's will cross cancel. Don't make the mistake of canceling these c's with these c's. They're horizontal. They're both on the bottom, so they are not going to cancel. It looks like we're left with a times a in the numerator, b times b times b, and then all of these c's, 1, 2, 3, 4. So simplify, a squared over b cubed, c to the 4th. Okay, once we start putting plus and minuses in here, things start to get more complicated and we have to use polynomial factoring. We can't just break things apart. That only works when they're monomials. So polynomial factoring in this numerator, there's a GCF here of x. We take x out, we're left with x plus 1. In the denominator, there's a GCF here of 4. So take a 4 out, you're left with x plus 2. Times, all right, this fraction, there is no factoring. There's no GCS. So we're ready to reduce. This x plus 2 reduces with this x plus 2. This x reduces with this x. We're left with x plus 1 in the numerator over 4 in the denominator. This one is starting to get very complicated because of all these pluses and minuses. So always looking for GCF. This is a standard trinomial. This is a more complicated trinomial. You're going to have to use either AC method or square root method or something on this. And this is the difference of squares. So we got all different kinds of factoring going on. Starting with GCF in that numerator there. Take an x out. You're left with x plus 5. In the denominator, it's a standard trinomial. So x times x, plus and plus, factors of 15 that add to make 8 are 5 and 3. And at this point, you can, if you want, cancel this x plus 5 here because it's okay to cancel things when they're on top of each other, numerator and denominator. Or you can wait and see. It might cancel with something over here, but it can't cancel with both. You can either do it here or this way. It doesn't matter. You can wait till the end if you want. In this rational, the denominator is going to be a little bit easier because it's the difference of squares. So if you know that pattern, you know that's going to be x plus 5, x minus 5. The numerator is a little more complicated because of this 3 here, but we might have room down here. Got a lot of white space down here. Let's write it down here so we can do our square root factoring. 3x squared plus 13x plus 12. And I'm going to zoom down here. If you're using the square root method, you multiply the first and last terms by the 3, which is the lead coefficient here. That gives you 9x squared plus 13x plus 36. And then you square root the first term. That'll be 3x times 3x. Bring your signs in, plus and plus. Factors of 36 that add to make 13. 9 and 4. And then you divide by the GCF of each binomial. And that will leave you with x plus 3, 3x plus 4. Let's zoom that into our rational expression here. X plus 3, 3x plus 4. And now we can talk about what reduces. This x plus 5, like I said before, you can reduce it with this one or with this one, but not with both. So let's just do that. This x plus 3 will reduce with this one. And it appears that that's it. So we're left with this x times 3x plus 4 for the numerator over x plus 5, x minus 5. Okay, let's go to the next page. On this page, we have 4 examples, practice problems for divide. So the only difference between multiply and divide is the rule for fractions. Keep the first fraction, change divide to multiply, and flip the second fraction. And then we proceed as we did before. And I'm going to use prime factors on this example. 11 is prime, 14 is 2 times 7. 28 is 2 times 2 times 7, 4 times 7, and 33 is 3 times 11. And now I can cancel the 11s, I can cancel one of these 2's, and I can cancel that 7. So it looks like I'm left with 2 thirds, 2 over 3. So the only thing new with divide is this rule. Keep the first fraction, change to multiply, flip the second fraction, then you do everything the same as multiply. You factor and cancel. So let's do it with variables. We're going to keep the first fraction. We're going to change to multiply. We're going to flip the second fraction. That's a 5. And now we're going to break it down into factors. 3 times a is 3a, c to the 4th times c to the 5th. 9 is 3 times 3, a squared, b. So I broke this 9 apart to make it 3 times 3 as I was breaking the a apart also. Now, what can we cancel? Well, this 3 will cancel with this 3, and an a will cancel with this a. These 4 c's can take out 4 b's, and it looks like we're left with, in the numerator, a c, and in the denominator, a 3 and an ab. And that's our final product. All right, once we put pluses and minuses in, we have to do polynomial factoring. Don't forget, this is going to change to multiply, and this fraction is going to flip. And I'm going to rewrite that here to the side, like I did in the lesson, so that I don't forget to do it. This is gone now, and this is multiply. So when I look at this rational, there's no GCF up here in this numerator, and it's not the difference of squares, so this is not going to factor, and of course this is just the one factor of x. So there's no factoring for this first fraction. We're changing to multiply. When I look at this second fraction, here in the numerator there's a GCF of x squared. When I get the x squared out, I have x plus 2 left. Now, you might want to not write this as x squared, and instead write it as x times x, because I can see already one of these x's can cancel with one of these, and you won't see it if you write it as x squared. So write it as x times x. In the denominator, I have a GCF of 2x. And then if I take a 2x out, I'll have 3x plus 2 left. Now what can reduce? Like I said before, this x can reduce with this one, but guess what? This one can reduce with that one. And this 3x plus 2 can reduce with that 3x plus 2. So it looks like in the numerator I have left x plus 2 from here over only the 2 from here. Do not make the mistake of reducing these 2's. This one's okay to reduce, but this one is not because it's being added to something. It's a term. So this is your final answer here. All right, and of course, the very last one is the most complicated of all. All right, I'm going to flip this fraction first off so I don't forget to do it. 2x squared plus 5x plus 3 over x squared minus 16, and now this is multiply. This one's gone. I'm doing this because that's the rule for division of fractions. You keep the first fraction, that's this one, you change divide to multiply, and you flip the second fraction, so now we have this. And now we have to factor. So we have a standard trinomial in the numerator, so that would be x times x. Bring in your signs, they'll be negative and negative. Factors of 8 that add to make 6 are 4 and 2. And then the denominator. There's a GCF here of 2x. And once we get that out, we're left with x plus 1. That's going to be times. This fraction we flipped, and I wrote it over here. The denominator is easier because it's the difference of squares. Perfect square minus a perfect square. So you should know this pattern. That would be x plus 4, x minus 4. The numerator, we're going to have to use our square root factoring for. So 2x squared plus 5x plus 3, I'm going to scroll down here. 2x squared plus 5x plus 3. And I'm going to use my square root factoring on this. Multiply the first and last terms by 2. That gives us 4x squared plus 5x plus 6. And then square root the first term. That would be 2x times 2x. Bring in your signs, plus and plus. Factors of 6 that add to make 5 are 3 and 2. And then divide by the GCF. So that leaves us with 2x plus 3 times x plus 1. Dividing both of these by 2 gives you x plus 1. 2x plus 3 times x plus 1. And so that's what we're going to write here. 2x plus 3 times x plus 1. That was just the factors of the numerator here. We did it down toward the bottom, and it came out to be this. Now what can we reduce? It looks like an x minus 4 can reduce. Just like that. And an x plus 1 can reduce. Do not make the mistake of reducing this 2x with this 2x. This would be fine, but this is part of a binomial. It's being added to something, so this cannot reduce on its own. It can only reduce with another binomial that's 2x plus 3. So it looks like that's it. It looks like we're left with this binomial and this one. So x minus 2 times 2x plus 3 over 2x times x plus 4 from here and here.